Hello, everyone. Welcome back to our session for the day 4 of RISE Summer School. So for this part, we will have Maxime and Marta for this very exciting talk from an idea to a paper. Maxime is a postdoc researcher at the Institute of Machine Learning for Biomedical Imaging at Helmholtz, Munich. And then his research is focusing on representation learning methods that aim to acquire low-dimensional representations of high-dimensional data. And Marta is a PhD student at the Institute of Machine Learning for Biomedical Imaging at Helmholtz Center Munich and then the Technical University of Munich. Her research includes generative AI, foundation models, and their applications in cardiology. And Maxime and Marta, the stage is yours, and then we'll start. And then sorry, just one more. During the presentation, if you have any questions, you can use the Q&A function to type in your questions, and then we'll answer. If it is a question to the presenters, we'll probably answer it after the presentation. Yeah. Okay, I'll hand it over to you.
Perfect. Thanks a lot for the nice introduction, and thanks again for the invitation. Marta and I are quite happy to present today to all of you, and this talk is about from an idea to paper. Nina introduced us a bit before, but we prepared some slides, so I will do it briefly again. So we're both part of the chair of Professor Julia Schnabel here in Munich. She's a professor at the Technical University in Munich and head of institute at Helmholtz Munich. And she was general chair at MICCAI 2024. And that's why we talk about a lot last year about submitting to MICCAI and how we can do a good contribution to MICCAI and share practical tips within the group to succeed to make our idea a paper. So maybe we introduce Nina introduced us, but she didn't talk about maybe our experience with MICCAI, so I will mostly present this. So I attended MICCAI for the first time in 2019 with a workshop paper. I also submit a different workshop paper since different MICCAI edition, and I had one accepted paper from MICCAI last year on the main conference. Marta, if you... Yeah.
Yes, so my experience with MICCAI, I went for the first time last year, and I had my paper accepted into the main conference as an oral.
And so the idea of this talk is to try to share our two points of view on how to bring an idea to a paper. Marta, she's starting her PhD last year, and I'm now 3 years experience postdoc. So more, maybe more advanced, and I've attended several MICCAI. So yeah, we'll try to give tips from a more senior position and for also a young PhD researcher. But before starting, we wanted to say this small disclaimer that we will not give you the perfect recipe to bring your idea to create a paper from this, because for example, both our paper got rejected this year. And the aim is to give you a bunch of tips and ideas from experience from our group and ourselves. And we also want to say that things can also vary a lot between lab and project. And we will try to share the experience that we have in our lab, but it cannot be generalized to every labs. So yeah, so let's start by setting up the stage. And we wanted to start by a bit talking about the meat of the big idea. And when you say to people, you're a scientist, often people think that you just one day have a eureka moment and you're solving a big problem at a time. But in reality, scientists know that this is a hard, long process, and there is many day where nothing is working and it's really hard. But when I was a PhD, I was also trying to have this eureka moment, trying to have this big idea or this big leap. And I think it can really, sorry. it can stop and stop a bit and decrease our progress. So for young PhD students, I think like starting is the hardest part. And you should not look for the big idea because it can embarrass your progress. And if we talk about the differences between the myth and the reality, it's like you're looking for sudden inspiration, one big leap, and a genius moment that will happen and will solve, I don't know, your PhD or a big problem. But in reality, creating ideas are more an accumulation of small ideas that you have a long time. You need many iteration, and it often come from frustration and refinement. And we want to hear in this presentation to talk about and show how real research often begins and give you tricks along the way of this process. Okay, so how research idea formed. So I find this nice graph that saying that most of the ideas that we have are by taking a shower. So I find it a bit true because when I'm working for a submission, sometimes coming back from work and taking a relaxing shower, I'm thinking about work and I have this, why didn't I try that today? Or I can do that tomorrow. But my tips here will not be to take more showers, but maybe talk about different sorts of ideas. And there are a few examples that exist. So if often come from frustration, tools, model, or data. By experimenting a lot, you will see some limitation of some method, and it can really come from frustration. You can also have idea from gaps or contradiction in the literature. Normally, when you're starting your PhD, you will do an extensive literature review. So you can also identify some gaps. They also can come from unexpected experiment result, where you observe something that you didn't expect and you conduct further analysis on this. It can also bring some ideas. And for me, nowadays, I will say that the source of idea that I have are mostly from informal discussion, reviews, and feedback. Talking about your research when it's working or when it's not working with different people and trying to explain what's not working will often bring you some new ideas, some things to try. And I really encourage students to do that with your professor, but also with other people from your group. And a practical tip that I'm trying to use is not easy to do, and I'm trying to do it. It's keep a notebook or an ID log. So for example, when I see a nice method or a nice paper, or I'm hearing a nice talk and I have an ideas, go to this log, write the ID with a catchy name, like genius, innovative method A to solve this. Link to a paper and write a sentence about it, why it's really nice. And when I'm finding some solution or trying to find some new idea, I go into this ID log, and by writing it, I also put it in my head, so I have better chance to think about this later if I need it at some point. Now we will talk about from an ID to questions, and even from an ID to paper. And an idea, it's not easy. You will not go straight to paper. You need first to define your research question. What are you trying to solve? And through nonlinear progress, you might have a nice paper that will be accepted at a conference. But what's important to do from your idea is to narrow the scope. You need to define what exactly is your question and what you're trying to solve. And then you need to assess if is it novel or what's the novelty of what you're trying to solve. Is it feasible and is it testable? And by this defining the question, I wrote, is it novel? But for MICCAI, which is an AI applied to medicine conference, you can have different type of contribution. It can be a new method, so novel in terms of method. You can have a better analysis on a task or a specific research question, or you can have an insightful framing and to share with the community. So you should also consider all type of contribution and think about this when you're trying to define the question. Also, don't aim for your full thesis in one paper. One paper should solve one problem at a time, and a thesis it's a larger scope where you try to address a topic, and a paper is only addressing one specific problem of this topic. So define your research question to solve something, and don't try to aim to solve your full thesis. And to try to illustrate the different steps that we will talk about with Marta, we thought about it will be nice to have a thread along the presentation, and we say that it will be nice to have two examples where maybe we can illustrate all of these steps. So I will introduce now the two examples. So example A is adapting a method from computer vision to medical imaging. And this is the situation you're in. You read an exciting new paper from CVPR or your favorite computer vision conference on a novel method, and that can be applied to your task that you're working on. And your idea or your thought is, okay, this could work well on my data. Let me adapt it to medical data in my task. The second example, example B, it's starting from a medical problem with private clinical data, and you're in this situation. You are working on a challenging medical task using private data from the hospital or from a company. And your initial idea or thought, it's I have a real world problem, but I'm not sure what's the most appropriate method of framing to solve this. Okay, so now you had your first idea, you define a bit the question, and now how you design your research plan. So as I say, you should formulate a clear hypothesis or an objective. It will help you to keep the scope focused and guide the method and the thing that you will try. You should also define the approach and data needs and consider a realistic approach given the data you need. You should describe, okay, I want to compare again this method and this method. I want to use this data and data. And you should think in terms of feasibility and clarity. Simple and well-defined plans are more likely to lead to publishable results. If you're aiming too high, too fast, you might have not enough computer resources, not enough data, or you will forget some step along the way, and you will realize this only in the end. And practical tip, we will give you a lot of practical tip about writing, because writing, I think it's really helps you to have a better focus on your thinking and notice what's maybe missing. So just write 2 sentences or a paragraph. I will write your hypothesis, how you will try to study this hypothesis or objective, and how you will do it. So if we go back to our example, we go back to example A, where you're trying to adapt a computer vision method for medical imaging, and your hypothesis can be, this novel method A outperform SOTA method for a specific medical task? But this hypothesis is still too general. You need a more precise one. So outperform, what does it mean? In what aspect do you want to outperform? Often, method, when you compare them with different metrics for different tasks. So what do you want, in which aspect do you want to outperform state-of-the-art methods? Are you trying to overcome certain limitation of these state-of-the-art methods? Or against what do we have to compare this method? And defining this comparison, it's really important to see what you need to implement and the experiments that you need to do. And also an important question, on which data you will try this and for which task. If we go back to example B, where you have a real world problem scenario, but you're not sure which method you should use to solve this. And your hypothesis will be, can I solve this medical task B by using state-of-the-art methods? And what are the limitations of this method? but still it needs to be more precise, like which kind of method should I use? How do I evaluate this task in terms of metric? What you need to use? And what performance am I expecting? If it's a really challenging problem, you will not expect to have 90% accuracy for a classification task, and you should be able to estimate by reading the literature on this topic what people are usually performing on those kind of tasks. And for MICCAI and for general conferences also, if you are using a private data set, it's really important to try to consider to have similar public data set where you can also test this hypothesis. And earlier you're thinking about this, earlier you might find solution and think of a nicer paper where you can include public and private data set. So now you define your question, you need to plan the experiment and the structure. You should always start by simple experiment early, and you should first probe the idea. So run small scale test or sanity check to feel your idea holds potential. You don't need to run first in the full on the full data. You don't need to compare against all of the methods, but maybe only the best one and only on certain aspects, but start with small experiment. When you're more advanced and you're starting to have more experiments and you idea hold potential, drafting a papers collection early will help you to define better your story that you can tell, and also seeing maybe what's missing. And if you go back to the first step where you define your research question and you're writing the first paragraph and the first hypothesis, maybe your first result will have changed this hypothesis a bit and you need to redefine this, and starting thinking of a paper will help you to be sure of you telling the right story. And yeah, so as I say, a lot of advice about writing, because for me it's for clarity and reveal what's missing. And one practical tip when you're thinking of an experiment and a hypothesis that you want to test, always try to sketch first the table of results that I want, and then just need to run the experiment where the cells are still missing. And it helps me a lot to see, okay, I need to do that, need to do that, and need to do that, and structure the experiment that I really need. Okay, I will pass to Marta now. Yeah, stop sharing the screen. Okay, we can see your screen, Marta.
Okay, great. Yes, so now let's talk about the results and actually doing the work. So in practice, you can't really expect that the process is going to be linear. It's probably going to take a lot of iterations of going from your idea, then testing it, realizing that maybe it doesn't work, and trying to reframe it. So there's going to be a lot of partial failures, debugging, and then sometimes you might even start with one idea of something that you want to do, but then you realize your method maybe works for something else. So there's a lot of reframing that is probably going to happen. But what is important to do is to always try to talk to your peers and then seek feedback, not only from your supervisors, but only from other people in your group. And then also try to revise often. And looking into our case study example, so how would we do the yearly experiments and iterations? So for the example A, where we are trying to adapt a method from some computer vision conference, what we would do is that our hypothesis would be whether this novel method would actually outperform SOTA methods on this medical task. So what you would do first is just try to test the approach on your data set and task, and then see, does it actually work or not? And then this can serve as your starting point. So then you can kind of see, like, is this actually working? And what can you do to make it better? And kind of, if it's not working, trying to look into the reasons of why it's not working. And typically the computer vision methods require some sort of adaptation to actually perform well on medical data, just because it's so much different than natural images. So typically there is some sort of adaptation that you will have to do. So even if the initial result maybe is not so good, then there's probably some adaptation that you can implement that will actually get the method to work better. And then looking into our example B, so having this medical problem and private clinical data that we want to apply it to, you would have to look into how can you actually solve this medical task by using the SOTA methods and what are the limitations of those methods. So that's also something that is important to look into. So in those methods, the author probably mentioned some limitations that you can kind of already see as, okay, maybe this is the direction that I should take. But what you can do in this case is that you can identify those potential methods that you could use for your data set and task, and then just try to experiment with them. And then you can see, okay, which one of these methods actually performs best, and how could you improve it? It doesn't necessarily like one method performing the best doesn't mean that this is the method that you should go with, because maybe you have an idea for another method to improve it, and then in the end it's also going to perform better. So it kind of depends on what idea do you have, what do you want to do, but it can just be a good starting point to kind of see how are the methods performing and what you can actually do with them. Another thing that would serve as a tip is that you should write as you go. So don't start with writing until you have all of the experiments finished and all of the results. It's better to start writing early, as it can actually help you refine your ideas. So while you write, it can help you sharpen your message and also your methods. And then it can actually also give you some insights into what do you want to do with your method, what experiments you should do. So then it's not that you've done multiple experiments and in the end you realize, oh, actually I cannot have a paper from this, they won't support my message. So it's really important to kind of start thinking about your writing early on. And then the sections that you can kind of start working early would be mostly the introduction and the methods. And also what is really good about having those early drafts is that in the end, when you are before the deadline, it's going to be less overwhelming. And then also another thing that is important is to keep notes on some key insights and challenges. So even if maybe you don't use it now, it can be valuable for discussion or future work, and also just your future work, since when you do your PhD, it's not just about a single project, it's more of this big overall project that you kind of try to compose of those smaller ones. So really analyzing the results that you have can help you define what do you want to do for your next project. And then one practical tip would be to use LLMs to improve your writing. But what is important to note is that you shouldn't just try to write a full paper in one prompt. And I would actually say don't try to write a paper using the LLM, but mostly just use it for the editing. So do the writing yourself and then just use LLMs to actually just help you edit the paper and make it clearer. And now let's take a look at some possible conference paper timelines. So based on ChatGPT, the ideal plan would be that you start working on it around 6 months before the submission deadline. You will do some idea generation, exploration, and discussion. And then you would move into the literature review and trying to further define your scope of what you actually want to do in this project and in this paper. Then once you kind of actually know what you're doing, you can start with some experiments, feasibility checks, and then even further define what are you working on in this project. 2 months before the submission, you should probably start actually running full experiments and working on the figures and visualizations. And a good starting point to actually drafting the full paper would be around 1 month before the submission. That would give you a lot of time for proofreading. And then a week before, it's probably good to have like an actual nice draft that you can just proofread and then submit. And having it done a bit earlier than just, let's say, a day or two before the submission is just going to make it significantly less stressful for you. And also now looking at how this paper timeline would look at our group. So around 4 months before the submission, we would discuss the idea with the group. So we would kind of do a presentation with some preliminary results to the group. And in this way, we can get feedback from other lab mates that could help us with our idea. And yeah, just define the scope and what we want to do. Then you would go into some further experiments and feasibility checks of this particular work that we want to do for this project. And then the rest would be rather similar to what ChatGPT mentioned. So 1 month before, start drafting the paper. But what is also important to account for is when you should send the draft to your professor. So probably sending it around 2 weeks before is like a good deadline also for like yourself to send it to your supervisor, and that is going to give them sufficient time to actually read it and give you proper feedback on the paper. And then 1 week before, you would once again just kind of go into a proofreading and preparing for the submission. And now let's go into some discussion and then how to actually make it into a paper. So when you work on your project, once you actually have to make it into the paper, what is important is that you want to tell a story. So the structure of the paper, it kind of should pretty much tell you a story of something that you are trying to solve. So first, in the introduction, you would identify the problem and motivate it, like why do you actually want to solve this? And then into the methods, you would just describe what are you actually doing and what are you doing. In the results, you would just talk about your findings. And then in the end, you need to discuss what do those findings mean and what future work could it lead to. What is important is to use clear figures and concise titles around your paper so that it makes it easier for people to read and also for the reviewers to actually evaluate your paper so that they don't get confused with sections and such. And now going back into our case examples, let's see how you would actually want to shape the contribution of your paper. So now the first case, once again, is when we try to adapt some computer vision paper into a medical imaging work. So what you have already done is you simply tested the approach on your data set. And then hopefully you found a way to adapt this method to work better on your given task and data set. And in the end, that could lead to a contribution where you have this method, and then you would propose a domain, so for medical, specific adaptation of this given method to improve its effectiveness of whatever task you are trying to solve. And then in the case of example B, where you are starting with a medical problem, so what you already done is that you identified some potential methods, and then you hopefully also kind of figure out what performs best and what do you want to do with that. And then in your contribution, you can show that this given method with some adaptations, for example, for the given data set, given disease characteristics, can outperform other models, let's say in accuracy and clinical relevance. So there are a bit of a different ways in which you can shape the contributions depending on your starting points. But while we have those two examples here, it doesn't matter that, like, it doesn't mean that this is the only two cases that could happen. There's a lot of different ways in which you can shape your contributions and a lot of different starting points. So don't feel like this is the only way in which it can go. And now let's look into some MICCAI specific paper writing tips. So obviously MICCAI is a medical imaging conference, so we want to ensure that there is clinical relevance in your paper. Is it something that you need to articulate clearly? probably in your introduction section, you would need to really state like, why is this important in the clinical terms? And you have to justify why this method is actually needed in a clinical setting, so that you are not just trying to solve something that no doctor, for example, wants you to solve, that no one needs solve, that your method is not like an overkill. And then also try to tie your results to the clinical utility, not just metrics. So don't just talk about the numbers, actually try to show how does it show clinical utility. And another thing that is important is that when you write for MICCAI, the audience is a combination of people with both technical and medical backgrounds. So you kind of cannot just assume that, let's say, if you are more from a technical computer vision background, that if you go straight into some deep technical details that people will understand, because there is going to be a lot of people that won't. So you really need to make sure that your paper is clear and you don't use any domain-specific jargon, and that you kind of explain the idea really from the bottom. So kind of starting with the most basic idea and then bringing it to what you're actually trying to solve, so that really everyone can understand what you're doing. And then what is also important with MICCAI is to include some baselines and also ensure reproducibility. So one way in which you could look for some recent baselines is to look at previous MICCAI papers that you can compare against. And for your reproducibility, it's important to release the code. So also, for example, when you look for papers from previous MICCAI and you see that they have code, the possibility of you actually trying to use them in your paper is way higher. If they don't have the code, then you probably won't do anything with it, just because it requires way more work. And then even when you think you coded it properly, maybe there are some bugs that you are not aware of. So it's just way easier to actually try to reproduce and compare against methods that do have the code released. So then it's also important for you to release your code so that other people can compare against. And then also, one thing that is really nice is that if you can actually use a public data set for the evaluation, so that then when you have the code released and also did the work on some public data set, then people can actually try to reproduce your results and see if they can also do it. If you don't have any public data sets, that's also okay, like it happens. But then that makes it a bit harder for like other people to see if they can actually reproduce your results. And also, one nice tip is to browse accepted papers from previous years and then try to study the structure and the presentation of their work. And you can also see, like, for example, what experiments they included to just kind of further guide your work. So that's probably something that is nice to do early on when you are just planning to submit to MICCAI. And then also looking at the current MICCAI submission requirements. So for MICCAI papers, it's up to 8 pages of content using this Springer template, which is 1 column. So this is actually relatively little space, so you need to make sure that you are concise and clear. And also, I think starting from this year in the supplementary material, you cannot add any new text or tables and results, which means that in the main body of the paper, you have to be even more concise and make sure that you really include all of the most important information. So actually in the supplementary material right now, you can only include videos or code snippets. So I feel like that's rather rare. Like it has to be some very specific use case where you are actually able to include videos of your method. It doesn't happen that often. So pretty much it's kind of like you don't really have a supplement that you can use. And also what is important for MICCAI is to include those ethical considerations. So for example, if you are using clinical data, you should include a statement of ethical approval, and then also mention any data anonymization, consent, and IRB status if applicable. And what is important is to check the requirements every year. So don't just rely on whatever requirements that they were last year, or like how the papers that you saw from last year look like. Because, for example, in the previous years, we could have the supplement, and then this year the supplement was not allowed. So if you try to submit some more tables or results, it would probably end up being desk rejected. So it's really important to actually check it and make sure that whatever you're submitting actually fulfills the requirements. And then looking into some common pitfalls. So a lot of times people try to wait for this perfect idea, but it typically doesn't happen. So there is really no point in trying to wait for something. It's better to just start working on something, even if you don't think that this is necessarily like perfect or big. And also don't try to start with an overly ambitious scope. So it's better to kind of build it from the ground up, start with something basic, and then try to build it up into something, let's say, more complicated. Also, I already mentioned this, but don't wait with the writing until all of the experiments are done. Because, for example, you might realize that, oh, you want to motivate your work like this, but the experiments actually show something else. So in the end, you either have to totally revise what you want to write your paper about, or you just need to redo your experiments from the beginning. So it's kind of really important to think about it as you do the experiments and try to see how you write the paper and actually write it before this is all finished. And another thing is is underestimating the time for polishing and revisions. So revisions can actually take a lot of time. I feel like a lot of times when we start writing the paper, we kind of go section by section, and then we don't really try, like in the first drafts, you don't really have this story. It's more of separate sections that you write. But then once you actually start revising, you can really connect those sections and turn the paper more into a story rather than just separate section by section that doesn't really connect. And that's something that is really important and will make your paper way nicer. And also another thing is that now, obviously, probably most of us is using LLMs. So how could we actually use it for the submission? So I would say use it for the editing and not the writing of the paper. Especially with LLMs, you don't really know what they generate. So you don't want to end up in a situation where you just use something straight up from an LLM and then it ends up just being something from another paper. So what you will want to use it for is for editing. So let's say clarity in grammar, like polishing the academic language, fixing grammar, and also enhancing fluency. Some rephrasing. So for example, if you struggle with explaining some technical concept clearly, that could also help you with that, but hopefully doesn't change the meaning. So you need to also make sure that the meaning is not changed. I feel like LLMs kind of do it a lot. And then also refine iteratively. So don't just try to like edit the entire paper in one step with one prompt, rather just do it step by step, let's say section by section. And another thing that you could do is to prompt the LLM to act as a reviewer. So for example, you can ask it to generate reviewer comments. Let's say you can prompt it with your MICCAI reviewer, what are the 3 strengths and weaknesses of this paper? And then you can kind of address this before a real reviewer is looking at your paper. And then also identify missing elements. So we can just ask the LLM, like, what is missing in this method section, or does this experimental setup support the claim contributions? So then we can kind of see what you're missing. And I feel like also nowadays, a lot of the reviewers will use LLMs. So if you kind of address the LLM's comments before submitting the paper, then maybe they will also give a nicer comment to a reviewer that is trying to use an LLM. And then also some tips, further tips. So yeah, checking the submission requirements yearly. It's something important to do. And also like a good tip would be to just start writing your paper in the template and don't try to just like try to fit the paper into the template later on. Just start inside of the template right away. So you know that you are within the length limits and stuff like that. And then also for MICCAI, the submission questionnaire is long. So don't leave it for the last minute. There are some short things that you will also have to write. So check it before the actual submission deadline. Then also, while you prepare for the final push, try to build in this buffer time for polishing, proofreading, and just dealing with any unexpected bugs. And avoid uploading the paper just before the deadline. So there could be some server lags, and then in the end, you might not actually be able to submit it on time. So just try to submit it like sometime before, just to ensure that at least something is uploaded there. Yeah, ideally you would do it a day early, and then that also will kind of make you feel calmer, and you can always still fix any typos later on. But it can already be submitted. And then also at the end, read the abstract and the title. So a lot of the times those things are written first, but then you actually write the paper and you might go into a bit of a different direction than what you initially went with in the abstract and the title. So that will give you this opportunity to kind of revise it in the end and really make it go with that main body of the paper. So now looking again at our case examples. So how could you just kind of make this submission and state your contributions? So for going into the computer vision to medical imaging, you can just say that in this work, we introduce this novel method for solving the task by implementing some method. And we perform extensive experiments on 2 public data sets and then report SOTA performance on whatever task. And by this, we also perform some previous works. And looking at the case of starting with a medical problem, how you can kind of frame it is that in this work, we conduct an extensive benchmarking for solving some medical task B using, let's say, 2 public data sets and 1 in-house data set. You evaluate it on the state-of-the-art methods, and you show the limitations of those methods, and also propose a mitigation strategy to overcome them. And some final general tips. So in the end, it's going to be a reviewer that is going to read your paper. So while you write the paper, you also have to kind of think like a reviewer. So one thing would be like, would I understand it if I read it quickly and tired? Because, you know, like the reviewers, they won't always be in the best mood, or like they might try to read your paper really quickly. So you really need to make sure that it can be kind of understood easily. So yeah, clarity and structure matters. And then also be your own toughest critic. So try to identify the weaknesses before the reviewers can do it. Discuss your work early and often. So talk with the ideas, through the ideas with your colleagues, even if they work outside your topic. Sometimes they can give you some really good feedback on what you're working on. And then also get comfortable with uncertainty. It's just a part of research. And don't get stuck on your first initial idea. So like we mentioned, research is more of an iterative process. So really like the initial idea of what you started with might be absolutely different than what you end up with. So just don't try to get stuck with it. And also one practical tip is to try to ask a friend for a dry read. So someone that is not a co-author, and also like somebody that is not really knowing what you're working on, can spot some gaps or jargon that you are blind to because you work on it so much. So it really helps to kind of see the spots of your paper that are not easy to understand to somebody else that is not working on this. And the reviewer, like while they should be familiar with the topic, they are not like familiar with what you did. So they have to be able to easily understand your paper. In conclusion, we can say that most papers start from some small observations. So once again, don't try to wait for this perfect big idea. Focus on asking good and focused questions. And through this, you can probably get some nice ideas and nice contributions. It's important that the structure to structure your work, then do it in an iterative manner and start writing early. Those points would be the keys. And also remember that research is messy, but I'm sure you can manage it with some tools and good habits. Thank you for your attention, and now we can go into questions.
Thank you so much, Marta, and also Maxime. So we can see from our Q&A session, there's already 2 questions that is, I think, both related to the use of LLMs. Could you please maybe answer to those 2?
So maybe first talking about the reviewer part. So I think I don't know what they said earlier. I think it can change between conferences. Maybe it's not allowed for MICCAI, but even if it's not really allowed, I think most of people will still use it. So I think a lot of people will use a LLM to review paper or to to review paper. Sorry. And in terms of feeding your novel research into a LLM, I think it's more when you're feeding to like something like GPT. Marta, do you have an opinion on this?
I'm not sure, actually. I never really thought of whether it could really leak the contents, but I don't know, like for me personally, like I never put the entire paper into ChatGPT or those methods. I kind of, if anything, go just through the sections, or let's say some like sentences that I feel like maybe I could have written better. So I feel like in the end, it wouldn't have like a full overview of my method. But then also in the end, like you will probably put your paper on archive, which is also like a good thing to do, because then it's already out there under your name. So in the end, like even if it maybe just already has some knowledge about your method, like in the end, soon after the submission, you can put it on archive, and then it doesn't matter.
Yeah. And I think also there is also some, for example, at where we're working in Munich, we have AI that we need to use for our work, or like if it's related to Helmut's where we're working. And so here there is more data protection. So maybe you can use someone that your work is providing with more data protection than the general one with ChatGPT. Okay, I will read another question. I'm unsure whether to begin writing my paper early because in my experience, the methodology often evolve significantly during experimentation. For that reason, an iterative approach to writing makes sense and the focus of the paper will change as the work progresses. So I think we meant by writing the paper early, it's not necessarily writing everything, but structure with bullet points, having name of section and subsection, and to see if you're missing something, and it will really help. And I think the methodology it's really the part that you think you can write early, but in the end you need to adapt a lot because your experiments will change. But I think there is some key component that you can already think of and details. And yeah, it's more about the structure than writing everything in details.
Yeah, I would also add that maybe like methodology is not the best like section to start with, but kind of looking into the introduction and motivation behind your work, and what are you trying to frame as your contributions, then this is something that really links to your experiments. So what I think is really important is that when you do your experiments, you already know what your contributions would be so that they link, and then you don't end up with 2 disconnected things of what you think your method's contribution are and what your experiments are, because it can either link or not.
Yeah, and I think you're right. It is really an iterative process, so it will take some iteration, a lot of changes, and yeah, it will take time. So then, how long do you take to write a paper for MICCAI usually? This is, I think it's not easy to answer. There is many factors that can come into account. First of all, how experienced you are with MICCAI submission. and writing a paper. I think nowadays, with the help of LLMs, you can write faster, but it can also be messy, so it's a long process. Also, how experienced you are in the topic that you're writing your paper in. I think if you're working for a long time in the topic, you know the main references, it's easier for you to draft the structure, the introduction, because you know the main paper, and it will be easy to readapt to the question that you're answering to this paper. But in general, and I think it's what we say, it takes the whole process take a month, I would say, by adding the template, create the structure, having the first draft, adding the figure and result. That can also take a lot of time, because I think figures table are really, really important in a paper, and it's a long process. And then you sending to your professor, then some iteration or some comments from the co-authors. So I think it's a month, in a month it's manageable, but early as possible. It's nice, as we say, that structure the paper and start thinking about it. Maybe Marta, the next question for you. Should there be a separate section for paper contribution?
So that wouldn't necessarily be a separate section. You would usually put it into the introduction, but sometimes you can like clearly kind of do like a subsection where you say that those are the contributions. So it kind of depends on your writing style, but I would say like most of the time people just put it inside of the introduction as the last paragraph, and then maybe you can write it in form of bullet points or just a paragraph. But yeah, it's typically inside of the introduction. So you kind of build up the introduction and then connect it to your contributions. How do this motivation actually leads to what are you trying to do?
Okay. The next question is like, can I use LLMs to suggest me ideas? I think yes. I will prefer to use LLMs to discuss some of my ideas, because I have the feeling that otherwise it will give you really generic ideas, really trendy, new kind of ideas. So I think, yeah, you can discuss your idea with it, but as we said, there is many things to do to create some ideas, and it will be small idea and small steps. But do an extensive literature review, try to start experimenting. Usually you have a PhD topic and your supervisor will guide you into the first experiment. So start experimenting with it, look for limitation, and it will help you to find ideas. But yeah, discussing your idea with LLMs, it's relevant also. Maybe I will take the next one also, because I have a bit more experience, Marta. So do you think it's get easier to write a paper, or we struggle every time? I think I will say nowadays I'm more used to the process of writing the paper. I know the key element and the main part that I should really focus on. The tips of structure the experiment, really write the right hypothesis really helps. So I would say I will go faster and less struggle, but it's always a bit stressful, and it's so, yeah, if you're working towards a deadline, there is still some struggle every time.
Okay, so then maybe I can try to answer the next one. So it's what's the most important thing to highlight in your results section? So I would say that really depends on your contribution. So probably one thing that you do want to make sure that you have is having those baselines that you compare against other methods, and you do show that your method actually outperforms them. And then like you would also want to have an ablation study. Like let's say if you have multiple parts to your method, that you show that actually each part of the method like has a real meaning and actually improves the results. And it's not that you just introduce something because it sounds fancy and is a contribution, but actually lowers the performance. So I feel like kind of the two most important things to highlight would be just outperforming the baselines and then having those ablation studies. But then it's also important to kind of look more into like why your method is working and analyzing that. But so I would say that's more of like related to your contributions.
Yeah. Maybe I can add something on this. So sometimes also MICCAI paper, it's quite strict and you need to go straight to the point. And I think it's important to think on the result that you will display need to correlate what you're claiming in your contribution. So if your contribution is A, B, C, you should have clear figures or table showing that, we contribution A, we have this table that show that we doing that. And your second contribution is B, and you have this figure showing that, okay, we indeed demonstrating that we making this contribution, and you have an ablation study that where you show that your third contribution C. So so when you have too many experiments or things like this, you should focus on correlate the result that you have and with the contribution that you want to claim. So I think there is question more about the summer school. And yeah, I think you can approach us for any discussion. It will depend on the topic, but you can definitely send us an email. And is it difficult to make it to the MICCAI main conference? So I think it's around 25 to 30% acceptance rate. So this is challenging for sure. For example, Marta and I, we use all of the tips that we gave you in this presentation, and we were both rejected this year. So there is also a part of uncertainty and reviewer, and it's a long process. But I would say it is difficult. Okay, so I think we answer all of the questions from the chat, if I'm not mistaken. And we're also coming to the end of this session, so.
Thank you so much. And thank you so much for the talk. First of all, I think it's very practical. And then all of us, especially, just like we see this new comment in the Q&A session. Thanks. Like it is really a great section. And then it will be very helpful for people who have no experience in submitting their work to MICCAI. Thank you so much, Marta and Maxine, for this talk. And yes, as we come close to the time, we probably need to end this session. And then for everybody, because I saw there's a lot of questions regarding the summer school, especially regarding the mentorship program. We actually have a lot of Q&As related to that in our summer school. So maybe if you have a question, you can always first try to search if there's an answer for that. And of course, you're also very welcome to just raise a question here or send us an email. And thanks again, Maxime and Marta. And then we will end this part of the session, and then we will jump into the next part. There's no break in between. So the next part is we will have 3 presentations of 3 MICCAI workshops. And then I wanted to mention that this is actually a follow-up from our session on Tuesday afternoon. Sorry, like a Tuesday, the last session is not afternoon for everyone. We will have 3 other workshops, organizers presenting their workshops. So if you're interested in the other 3 workshops, you can watch the recordings from Tuesday. So for today's session, we'll have presentations from the following 3 workshops: FAIMI, Emerge, and Agentic AI. So the first workshop, I see Andrew is already here. Could you do you need to share the screen? I guess so, right?
Yes, I will do.
Yeah. In the meantime, I would say, so the first workshop is Fairness of AI in Medical Imaging, FAIMI. And then this will be presented by Professor Andrew King. He's a professor at the King's College London. So let me see. Yeah, it seems like the slides are ready. So please go ahead.
You can see the slides okay?
Yes, the slides is perfect.
Okay, thank you. So yeah, I'm going to be talking about the Fairness of AI in Medical Imaging workshop, which stands for FAIMI. So because this workshop is all about fairness, I thought probably the first thing I should do is to actually tell you what fairness means, because not everybody knows what fairness means in AI. So my first slide is just to talk about what it means for AI to be fair or not fair. Basically, in simple terms, fairness means the absence of bias, which doesn't help you very much if you don't know what bias means. So I'm going to explain what bias is. And I'll explain this just using a simple example. So suppose we have an AI tool that's been trained to diagnose a disease based upon some imaging data. So in this case, it's some cardiac MR data, but it could be anything. It goes through your magical AI box and it gives you a diagnosis. So it tells you what disease the patient has. And let's say you test it on some test data and you find that it's working great. It has a diagnostic accuracy of 95%. So you might be really happy. And you might think about pushing this into the clinic and using it in the real world. But then you dive a bit deeper and you look at the data that was used to compute that 95%. And let's say we break it down by race in this case. And let's say we look at the races of the subjects and we find that 90% of them were white, 10% other races, which maybe is not a problem because it's doing well overall. But then we want to look a bit closer and we say, okay, well, what's the diagnostic accuracy just for the white subjects? And we find that this is fantastic. So 99% accuracy. So everything looks good. But then we look at the other races and we find that actually it's much lower. So there's a big performance disparity between the white subjects and the other races. It could, I've illustrated it here with race, but it could be sex, it could be age, it could be anything. But this basically is what I mean by bias in AI. So it just refers to different levels of performance for different groups. And it's common to call those groups protected groups because often in many countries, they're actually protected by law. So it's illegal. This is a form of discrimination to have different levels of performance, and it's illegal to discriminate against people by race, by sex, and by age in most countries. So the FAIMI workshop is basically looking at a broad range of top topics that are related to this idea of AI, fairness, and bias. And before I talk about the FAIMI workshop specifically, I just want to say what FAIMI is. So FAIMI is actually more than just a MICCAI workshop. So it's actually an independent academic organization. There was a few of us got together about 3 years ago now. We were all concerned about biases in AI in medical imaging. And so we formed this organization called FAIMI, Fairness of AI in Medical Imaging. And our aim is basically to promote this issue as a research topic and to publicize it, to try and encourage more people to get involved in this research area. Now we are also a MICCAI special interest group. So MICCAI has a number of special interest groups focused on particular research areas, sometimes clinical applications, sometimes methods. So we have a FAIMI MICCAI special interest group now. There's only a small number of special interest groups at MICCAI, and we're one of them. We have so far organized 3 free online symposia. So we started, 3 years ago. So the 4th one is going to be this year. And we've also done 2 MICCAI workshops so far, and the 3rd one will be this year in 2025. So there's a QR code there for our website where you can find out all about the FAIMI organization. Okay, so I'll talk now about the MICCAI workshops because that's the most relevant thing. So there have been 2 MICCAI workshops so far. The first one was in 2023. We had 20 submissions for this one, 19 papers were accepted, and we had 4 oral presentations. One great thing about the MICCAI FAIMI workshop so far is that we've been really lucky in attracting some of the top names in AI fairness. And in the first workshop, we had one of really the big names in AI fairness, which is Judy Gachoya from Emory University in the USA. She's done some really groundbreaking work in AI fairness. She's very well known. Second workshop was in 2024, where we had 17 submissions, 15 papers accepted, and 5 orals. And again, we had a fantastic keynote speaker there from Google Research, Mercy Asiedo. talking about the relationship between, or the relevance of fairness in AI to the African context. We had loads of attendees there. It was at least twice as many as the first year, but actually we turned people away because there was no space in the room. There was people sitting in the corridors and standing at the doorway. So it was a really, really popular workshop. And that kind of reflects the way that fairness is going as a research field within sort of the MICCAI area. It seems to be really taking off in the last few years, whereas a few years ago, it was quite a niche area. Now it's becoming really mainstream. And this year, so this year's one hasn't happened yet, but we've already had more submissions than ever before. We've had 26 submissions. We've just accepted 20 papers, and we've already also got another fantastic keynote in Tal Arbel from McGill University. So I've said in general terms what the scope of the FAIMI workshop is, but I'll just go into a bit more detail about that. So basically, we're quite broad in our scope. So if it's got something to do with fairness, then it's within scope. So there's a list of example topics here, but these are not sort of the only topics that would be relevant. So it's things like just assessment of bias in applications in medical imaging, healthcare inequalities and the role of machine learning in addressing these, discussions of definitions of fairness, applicability of fairness in medical contexts, bias mitigation strategies. So even papers on ethics, not technical papers, are also within scope. Papers discussing legal and regulatory issues, causality and fairness, and the interplay of algorithmic and dataset bias. So there's a lot of topics there, and other things would also be considered, so long as it's got something to do with bias and fairness. One thing I would say here is that although in the MICCAI workshop, the main MICCAI workshop, I think there's quite an emphasis on novel methodology. I think in the FAIMI workshop, our emphasis is on a novel contribution. So I would say start from what's known already. Think about what do we know about this, the field, the subject that you're interested in. What don't we know? And then how can we go about finding out what we don't know? So that's a contribution, finding out something that's not been known before. If you need novel methodology to answer that question, that's fine. Novel methodology is okay, it's within scope. But if you can do that with existing methods, that's also fine. So there is no strict requirement for a novel deep learning architecture, for example. So why would you submit to MICCAI FAIMI? It's a great way to showcase your research to a global audience. So MICCAI, as I'm sure you know, is one of the premier conferences in medical imaging. MICCAI FAIMI is getting super popular these days. So we're expecting a lot of attendees at our workshop this year and next year. So it will be a great way to get your work across to that audience. We have some quite big names involved in FAIMI. So and many of these will be attending the FAIMI workshop. So there's a few names there, but these are all people that are very active in fairness and quite well known internationally. So it's a great chance to engage with that community and really sort of network, make good contacts. I also think it's worth doing this kind of work and submitting to this workshop, but just because it's worthwhile. I think there is a serious ethical concern about many AI models that are out there at the moment. People are training models, people are even using models in clinical practice. Not many people are thinking about how these models perform for different subgroups. You know, what are they actually learning to do? So I think if you've got a model that's discriminatory, I think there's an ethical imperative to look into that from a research perspective. And you get a great publication as well. So just like all the MICCAI workshops, we publish our proceedings in the Springer Lecture Notes Computer Science series. We also have awards. So the specific awards that we have, we generally have a best oral and a best poster award. So that's the award winners from the last MICCAI workshop in Morocco. We also have travel awards, and the specific travel awards that we have that varies from year to year, but we get funding as being a MICCAI special interest group, and we tend to use this funding to sort of give scholarships to people to attend the workshop. So in the first MICCAI workshop, or the second MICCAI workshop we had in 2024, we had 4 awards that were given to authors from low middle income countries that just covered the registration. This year, we only have one award, but that's what we call this the FAIMI Horizon Award, but this covers everything. So you get your flights, your registration, and your accommodation paid. And the criteria for this are to be the first author of a paper at FAIMI, to be an early career researcher, to be attending MICCAI for the first time, and to be from a diverse or underserved background. So we're very keen on engaging people from different areas to take part in FAIMI. We haven't yet decided what the travel awards will be for next year's FAIMI workshop, but it might be something similar to this year's. So to submit to FAIMI, it's the same process as submitting to the main workshop. So you prepare your paper, it has to be anonymized. I'm sure you've heard all about these requirements already, 8 pages and 2 pages of references. You use the LNCS format. And for us, the different workshops use different submission platforms. We use the CMT platform. The dates for next year are obviously not decided, but just to give you an idea, these are the dates for this year. So submission, all of the workshops tend to follow a pretty standard calendar these days for submissions and decisions. So for us this year, we had the submission deadline 24th of June, decisions 16th of July, camera ready version 30th of July, and then obviously the conference sometime in September normally. Okay, so as well as talking about the workshop, if you're interested in fairness or if you want to get involved in fairness, then we would be very happy if you were to stay engaged and involved with the FAIMI organization. So we have a newsletter, so you can scan that QR code to sign up for our newsletter to be notified about future events and initiatives, including the MICCAI workshop, but also the other events that we run. And we also have a Slack community, so that's a great way to just engage with other people that are interested in this field. Ask them questions if you're not sure about how to do something. People post there, and sometimes the organizers will chip in and give answers. So it's a nice, friendly community to ask questions about this and stay engaged with people. Okay, that's everything I had to say. I don't know if we take questions now or later.
I think maybe we can take a question now, as I guess it's more refreshing just after you present. There is one question in a Q&A session, which is about, it says like a new example about bias and discrimination in medical imaging at start. Could you touch upon it with another example? I'm confused. How could a computer or algorithm know if the set of scan is from white person or a person of color? Or there are some structural differences in autonomy that the model don't understand because it could have been trained on images or scans of one of the groups?
Yeah, that's a really good question, actually. And so one of the first keynote speaker we had in the first MICCAI FAIMI workshop was Julie Gichoya, and she wrote a really famous paper now which showed that you can actually, AI can actually tell what race somebody is from many medical images, many different medical imaging modalities. So you might think that a Black person's heart scan or their chest X-ray looks the same as a white person's heart scan or chest X-ray, but actually AI can tell the difference between these things to quite high levels of accuracy. So there is a subtle difference between the images. And if you train the models on imbalanced data, so like mostly white people, for example, it will learn the features that are common in white people, and it will learn to use those better than the ones that are more common in Black people, for example, or men or women or old or young people.
Thanks. And then we see another question pop up. Ask, is there a link between fairness and explainability?
Well, I would say yes and no. So, I mean, they are different things. So fairness is just looking at this different performance between different protected groups. Explainability is obviously trying to see how models are working. But I would say there is a link because explainability can sometimes be a way of understanding why unfairness is happening in models. So you can see bias just by looking at the performance of the model. But if you really want to understand why is that model performing in a biased and discriminative way, then explainability techniques can be a really useful tool for looking into that a bit deeper.
Great. Thank you, Andrew. And then I think we'll keep the Q&A on. Like if you still have some questions, you're welcome to write on the Q&A part, and then we will come back to it after all the presentations. as now we probably wanted to move on first to make sure that all our presenters have their time to present, but we'll come back. And then, yeah. So our second workshop that we're going to present is the Emerge workshop, which will be presented by Naren. Are you there?
Hey, hi, I'm there.
Hello. Yeah.
Thank you very much for inviting Emerge to be presented over here.
Mhm.
Apologies, my camera isn't working at the moment. I tried to fix it, but it seems a technical issue. I hope I can continue the presentation as such.
Yes, of course. Could you try to share the screen if you need to
Yep.
share something? Yeah.
I hope my screen is visible.
Yes, it seems it works. Yes. Yeah. Please
Perfect.
go ahead.
Thank you. I'm Naren, and I'm currently serving as the president of the MICCAI Student Board. In the next few minutes, I'll walk you through how we support early career researchers and students within the MICCAI community as a part of the student board. And with today's particular focus on the Emerge workshop and our new doctoral symposium as well. So just to give you a brief idea about the MICCAI Student Board, our board was initiated in 2010 as a student initiative to represent and support young researchers within the MICCAI community. We aim to increase the student participation, we promote networking and bring student concerns to the attention of the main MICCAI board. And this year's board includes students from a range of research backgrounds and geographies. Each officer focuses on specific aspect from educational and professional development to also community events. So it's a collaborative effort. This year we have a largest board ever, around 14 members. Our year-round pillars. So our work is structured around 4 different pillars on research visibility, career development, skills and education, and also community building. These guide our annual set of events that we conduct. So for research visibility, we organize the MSB Emerge workshop, and it is in the second edition this year. For career development, we have 2 events, the MSB's A&I event and also the doctoral symposium that we have launched this year. We conduct year-round webinar series online and also the MICCAI Educational Challenge. And during conference, we have a bunch of sports and social events as well. Emerge was organized for the first time last year. We launched based on an idea that we received from Julia and Kareem, who were the general chairs last year. It is a student organized workshop by the students for the students, and it is designed to give young researchers a platform to present their work in a very constructive environment. Our focus is on mentorship, expert feedback, and also building a community of young researchers. So some of the important features of our workshop is to focus on early career researchers and also student-led research. And one could be a last author. A young scientist could be the last author. That is a preferred criteria, but not a required criteria. But we focus on projects where young scientists were the primary investigator or the lead investigator of the projects. We have mentorship and constructive feedback oriented oral presentations. That means we give ample amount of time for our accepted papers to be presented as an oral session, so around 20 minutes for each presentation. We also have a session chair for each who are from a area of expertise of the accepted paper. They would try to provide some constructive feedback to extend the paper to a journal version. And our keynotes are also tailored for the needs of young scientists. We also have a bunch of networking opportunities as a part of our broader workshop goals. And the accepted papers get visibility through the MSP's social media network. And the papers also are invited to be submitted to a special issue of Melba. With respect to tracks, we offer both archival and non-archival tracks. So in the archival track, we have the main workshop, and in collaboration with the Young Scholars Initiative, we also have a Pan-Asia track. Some of the salient features of a workshop include we have a rebuttal stage, and we selected open review as a platform for submissions. The reviews and rebuttals of accepted papers are made public. As like other workshops, we publish our workshop papers in Springer LNCS proceedings. And this year we started a non-archival track, which is basically a conference to workshop track. So if a young scientist is presenting a MICCAI poster, they can submit their paper for oral presentation in our workshop, and preference will be given to the focus areas and the focus target audience of the Emerge workshop. With respect to the scientific focus, the scope of Emerge aligns with both MIC and CHI, just like the main conference. We welcome methods papers, novel applications, benchmarking studies, data sets, in-depth analysis of certain problems, and we particularly emphasize on research targeting region-specific challenges. So last year we had a special track for African context, and this year on Pan-Asian context. Last year's keynote was by Professor Matthias Unberath, and the title reflected our goal of making Emerge a meaningful space for early career contributions. So we don't have keynotes focusing on any scientific topics, but on general aspects, the unspoken rules, a very informal and candid talk by our keynote speakers that might help students and young scientists. With respect to awards, the top 3 papers will receive $300, $200, and $100 respectively. And we will be extensively featuring the accepted papers through our MSB social media. And these are some of the pictures from last year's top 3 winners. This year's Emerge organizing committee is both from the MICCAI Student Board as well as the MICCAI 25 Young Scholars Initiative Committee. I would also take this opportunity to advertise our new event this year. We are organizing the MICCAI Doctoral Symposium. This is focused on doctoral students who are about to graduate or graduated within the last 1 or 2 years. It's a focus venue for PhD candidates to present their thesis work. And one of the important feature is the posters are to be presented alongside the scientific posters in the main conference for all 3 days. So our doctoral consortium has 3 different aspects. One is a poster session. The best posters will be selected for oral presentations on the second day of the main conference in a 3-minute thesis style competition, and that is called the PhD Thesis Madness. And all the submitted thesis will be presented in the Emerging Scholars collection. And we also have a bunch of social events. So if you are attending MICCAI this year, then feel free to join our social events where you can network with other students and young scientists. And if you want to know about a broader history of the MICCAI Student Board and our activities, we were featured in the AI Ready Healthcare. You could listen to that to know about our initiatives. And if you're interested in joining the MICCAI Student Board, the call will be out in October or November this year for next year's board. And do follow us on our social media to not miss an update. Thank you.
Thank you. Let's see if there's any questions on our Q&A session about our Emerge workshop. I don't think this one is for that. Okay. Maybe let us move on to the third workshop first, and then if there's any questions come up afterwards, we will go back to this. So for the third workshop for today, we'll have the Agentic AI workshop, which will be presented, I just got noticed, will be presented by Jianing, right? Please go ahead and then try if you can share the screen and everything.
Sorry, I cannot open my camera for some reason, so I just share my screen.
Okay.
Okay, can you see my screen?
Yeah, but now it's not in the presenter. Yeah, okay. Now,
Okay.
yeah, it seems good.
Okay.
Please go
Cool.
ahead.
So it's really great to have a chance to talk about our workshop, Agentic AI for Medicine, at the RISE-MICCAI Summer School. So I'm Johnny, one of the organizers of this workshop. So I guess many of you may have heard the terms like AI agent, Agentic AI, and AIM agent. They are pretty much the same thing, and there's no clear boundary between them, at least for now. So I will just give a quick background on what agentic AI is all about. So before the deep learning era, we mostly had a symbolic AI, things like decision trees and logic-based algorithm. They have strong interpretability, but they were very difficult to scale up and had a limited ability to manage images, free text, and other complex clinical data. Then came the deep learning era. So what we were first seeing was what we call task-specific AI. Basically, it only does one thing at a time. For example, only classify chest X-ray images with or without pneumonia, or only segment cells. So because they were trained on limited data and compute for that one specific task, if a person wants to use a model to do something else, they will need a new data set and to train a new model. In the past 2 years, there has been the rise of generalist AI, and one significant type of generalist AI is generative models, like large language models, for example, GPT, Gemini, text-to-image models, for example, Imagine and DALL-E, and also text-to-video models like Sora and Pika. So they can answer different questions and generate images or videos of different types. It's not like they can only answer, for example, 100 specific questions or can only generate 100 specific types of images. So we call this generative AI open-ended, meaning their output is potentially infinite. And another type of generative AI is foundation models. Although large language models are also called foundation models, the foundation models I mentioned here are not necessarily generative, but they are trained on massive data and can tackle multiple tasks within a specific area. For example, the segment anything model, SAM, it can almost segment any object, and the medicine model can segment different lesions, organs, and beyond. And also the Vision FM model, it can do classification, segmentation, forecasting, and other types of tasks for ophthalmic research. But crucially, while they are generalist AI, they are still only generalist in one specific domain. For example, only for ophthalmology or only do segmentation. So what are the limitations of these AI types? So first, they only have a single or narrow action space. For example, only do segmentation or chat. They were limited by what was in their training data. For example, their knowledge has a cutoff time point, and they have a low level of autonomy. They are pretty passive. They wait for us to give them input and instructions, and they don't really take initiative. And more importantly, because these foundation models are actually very good at their specialized domain, it appears that they could become part of something bigger. So this is where agentic AI comes in. So it essentially aims to transition from passively receiving inputs or instructions to proactively explore and address problems. So essentially from reactive to proactive. And instead of focusing on a very narrow scope, it aims to leverage a wide range of resources and intelligence to address problems quickly, accurately, and comprehensively. So basically from narrow, broad. But I have to be upfront because current agentic AI is still in development. It cannot solve everything. And honestly, its definition is still unclear. And this is one of the reasons why we wanted to host this workshop. But in general, agents follow a sense, think, and act paradigm. So for AIM agent, they use large language model as a digital brain. So in our recent paper published in Nature Machine Intelligence, we defined AIM agent as a system that can perceive information, plan and decide, recall and reflect, interact and collaborate, leverage tools and act. So a diagram of key components of an AI agent can look like this. It can perceive its environment. It can do high-level reasoning. It has both long-term and short-term memory, and it can use different tools. For example, those foundation models can become its tools. And an AI agent can even work with other agents to address complex problems. So why would we want to host this workshop? One reason, of course, is the rise and potential of AI agents to address medical challenges. For example, the recent BioMuni agentic system can use 150 tools, 59 databases, and over 100 software to automate medical research. And the agent hospital developed by Tsinghua University can simulate 32 departments and can diagnose over 300 diseases. Although there were workshops on foundation models for medical vision and large language models for life sciences, there hasn't been one specifically on AI agents for medicine. And also, as said earlier, AI agent is still new in the medical field, but agentic technology is moving incredibly fast. And there are also emerging risks and challenges. For example, cyber attack risks, as these agents can use external resources, for example, Google search. But opportunities are also massive. For example, they can potentially reduce timelines of drug discovery from years to weeks. And we are very fortunate and honored to host the first Agentic AI for Medicine workshop at MICCAI 2025. And we are very lucky to have amazing people join us with backgrounds across academia, industry, and medicine. For example, we have Professor James Zhou and Professor Marinka Zitnik, and also Dr. Guohao Li, the founder of Camel AI, and also Dr. Kyle Lan, who is a surgeon and a lecturer at Imperial College London. So what kind of work were we looking for? We wanted submissions on new theories, principles, and architectures for agentic systems, new reasoning and planning strategies, new evaluation methods and benchmarks, also topics related to large-scale data sets, applications, scaling law, interpretability, multi-agent systems, and also works addressing ethics, safety, privacy, and regulations of AI agents in medicine and healthcare. Overall, we received 17 submissions, and we accepted 8 for oral presentations and 5 for poster presentations. Here are the list of accepted oral papers, and we have applied research work, for example, using AI agent to analyze Alzheimer's disease. Here are the accepted poster papers. We have work using agent to audit the reliability of clinical vision models. I'd like also to share some comments from our reviewers and chairs. So for reviewers, about their comments, why a submission is not suitable or not too strong to be included in the workshop's proceedings. For reviewers, they prefer objective assessment and comparisons to previous approach. If human evaluation is the only way, they want to see a justified approach. For example, why these human experts were chosen and how human bias was minimized in the assessment. And for chairs, they mainly have concerns about the link to agents. For example, one area chair commented interesting application, but the link to AI agent is not clear. And the authors do not make it clear why AIM is required. And also purely narrative papers without any quantitative results were less likely to be accepted. And thanks to our sponsor, Cyborg and Bionic Systems, which is a science partner journal, we are delighted to present Best Workshop Paper and Best Poster awards to honor exceptional submissions to our workshop. Each award will receive $1,000, and the winners will be announced at the workshop. Yeah, thank you very much.
Thank you for the presentation. I can see that on our Q&A chat, there are some questions related to the Agentic AI workshop. The first one is how to join the Agentic AI workshop.
We plan to have a hybrid session. So our workshop will be held on September 27th. I think we will have the Zoom link shared to attendees.
Okay, and then I see there is another question. What are the use cases of agentic AI in medicine? Medical chatbots, which can book your appointment to doc, how is this not accessible with the general chatbot?
So some chatbot already has some agentic features, but of course there are many medical applications how should I say? For example, like the video editing, some doctors want to edit, for example, surgical videos for their presentation, and edit a surgical video. To understand the video, it may need to detect the object, to know the different actions, to know the face, and it requires many different kinds of models. And if you have an agent that can orchestrate different tools, different models to help the doctor to prepare his or her presentation, it would be very helpful for them.
I see. I can see that there is a question for Emerge workshop. Naren, are you still there?
Yes.
Yes, okay. Our participants have questions for you. If we have a paper that is related to a specific topic, why should we go for a merge workshop instead of going for a more specific one?
Yes, that's a great question. Yes, you have both options. You can, of course, focus on a domain-specific workshop if that suits you. From our point of view, we are more interested in researchers who require more feedback, more mentorship. So when they make a submission to our workshop, mostly where it is a young scientist-led research, where they do not have much of a mentorship, our team would be helping them in extending their work into a journal submission. So we help them match with mentors and participate in that journey. So for this year, as an example, we also work with the Young Scholars Initiative, where students went in for a 6-month of training program with a matched mentor, where they are told how to write, how to present a paper. So these are several other aspects that we focus on.
Sounds good. We kind of go back to agentic AI. Here's a questions about like whether the agentic AI for medicine is only for techniques like large language models.
You can also use like vision language models, like multimodal models to act as the brain of an agent. Yeah, but very common, at least for now, the agent is powered by large language model.
Great. Well, oh, there's another one for agentic AI. We'll go for this one first. It says that agentic, is it this question? Yeah, agentic AI can also work for histopological multimodal data where we want to integrate multiple data types by integrating LLMs along with vision models.
I think so, but I would suggest people have to identify if there is really a clinical need or there's really a need to use agentic feature to address their problem, right? So it cannot solve everything. So before you choose to use AI agent, probably you can try some other method first and to see how they work. If they fail, you can try AI agent. It's not like AI agent can solve everything.
Great. We have a question for Andrew. Are you still there?
Yeah.
Yeah.
Still here.
I see you unmute yourself. Yeah, great. So we have a questions for the fairness in medical imaging workshop. Explainable AI can assist doctors to assess AI models to trust or not. Does this hold value to have a personal AI agent for docs? Combining, yeah, agentic AI and explainable AI.
Yeah, I think potentially that sounds like a good idea. I mean, one of the uses which has been claimed for explainable AI is to improve clinician trust. I would say that we're not quite there yet. I mean, lots of methods have been proposed. I'm not sure how much difference they're really making to doctors' trust of understanding of these models. I think maybe a bit more work needs to be done, but in principle, I completely agree. So yeah, maybe, yeah, I don't know if the agentic AI person has something to say about this, but it seems like a good idea.
Would you like to comment something on this, Danny?
Yeah, we can give it a go, but I don't know actually, to be honest.
Okay, sounds good. Maybe I can ask the questions for all of you, but maybe it will be a little bit different for merge workshop because since the scope is a little bit less strict. Maybe let us have a question for both FAIMI and Agentic AI that if people are interested in those topics, do you have some recommendations of what kind of resources that can start to get to know to this field? And Andrew can go first if you're ready.
Yeah, I was being slow to respond because I was trying to get a URL to put into the chat. So we do have, if you look at the FAIMI website, we have a list of resources. Where do I put it? Into just chat?
Yes, but I'm not sure whether you can send it to everyone. I can also send it to everyone for you. I saw that you answered.
I'll send it to you and then you can post it around to everybody.
Yes.
So yeah, at the FAIMI website, I showed the QR code earlier on. So one of the parts of that website is basically a list of resources. So we've tried to summarize what we think are the key papers, like review papers to get you started, and then breaking it down by categories of different research fields within fairness. Also, software packages, software tools that you can download and help you to get started quicker, data sets that have demographic information and that can help you to do fairness work. So we've tried to, we're very keen to get other people to do this kind of thing, this kind of research. So we've tried to make it as easy and accessible as people as possible. So please check out that web page.
Sounds good. Jianing, can you give us a little bit insight of like if people are interested in this, how can they get started?
Yeah, sure. So there are some open source frameworks, for example, AutoGen from Microsoft and also Camel AI, developed by one of our speakers. If you want to use like multiple agents to address the problem, AutoGen and Camel AI and also Kulu AI would be one of the options. And Langchain, the framework, open source framework, also have many amazing agentic features. For example, it can do Google search and can process PDF and other types of documents. If you are working on, for example, report generation or some documentation tasks, you can try Langchain. Yeah, thanks.
Sounds good. I see some questions also from the Q&A. We will jump back to that. I have a question for Naren about the Emerge workshop. I can see that from the website, it's a workshop that's trying to empowering the junior researchers and students. And then you also mentioned that you have a lot of events happening during MICCAI. I was wondering whether you have also some events that maybe online or maybe through like newsletters or something like that to support people that who might not join MICCAI this year, for example.
Of course. So we do have a webinar series which we organize quarterly. And the MICCAI Student Board is also working together with the MICCAI Society's Career Advancement Working Group in running the continuous mentorship program. So we have around 200 mentors and mentees matched through our platform, where we try to match one-on-one with a senior academic or an industry person and a person requiring mentorship. So if anyone is interested in joining, the call is open throughout the year. We will be inviting them to the platform.
Nice. There's a little bit more questions. I think I'll go from the top. There's one question about, can you share the link to the Agentic AI site? I think I actually have it. I can type it later on the chat. And then we have a question regarding the FAIMI workshop. How can we seek mentorship from the FAIMI group? Andrew, do you have an answer for that?
So we don't have a mentorship scheme, but I know RISE-MICCAI has a mentorship scheme, and I volunteered as a mentor on the RISE-MICCAI mentorship scheme. So you could try to apply through that. But maybe the Slack group would be a good place. So I gave a QR code for the FAIMI Slack group. So if you go there, then you'll engage with lots of other researchers from around the world who are all working in similar areas. And as I said, some of the organizers will also be involved, and so you can ask questions there, and you might well get some help and mentorship.
It's really great to hear that you signed up as a mentor for the RISE-MICCAI mentorship program. Thank you so much, Andrew. And then, yeah, for people who are interested to work with Andrew, maybe this is a great chance to sign up for the mentorship program at our summer school. Okay. I think the next question is actually for Agentic AI workshop. It asked, I guess it's for the Agentic AI. Can the Agentic AI do summarization for pathology reports?
Yes, I think so. But the point is, if like for example, if like a vision language model can already do the summarization, so I mean, so let me have a think. I will go back to this question later. Okay. Is it
No,
okay?
no problem. No problem. No problem. We have, I think it's more like a comment than a question, that the iMimic workshop that we presented on the Tuesday seems similar to FAIMI. Andrew, do you want to comment on that?
Yeah, so somebody else asked earlier on about the relationship between interpretability and fairness. To me, they're completely different areas. Like we're not focused on developing novel interpretability methods. That's the, I mean, I've been to the iMimic workshop, it's very good, but if you're interested in developing novel interpretability methods, that's the place to go. If you were to write a paper on a novel interpretability method, it wouldn't get into FAIMI because it wouldn't have anything to do with fairness, unless you were trying to analyze a biased model and you needed some novel method, interpretability method to do that analysis, then it would be related to FAIMI. But to me, they're completely different areas. Most papers at FAIMI don't have anything to do with interpretability. Some do, some don't.
I don't know whether I'm allowed to comment a bit on this, because this is actually to explain to everyone, like my research focus is also on fairness AI. So maybe I can comment a little bit on this, that there's definitely intersections between these two areas. Like what Andrew said before, you can use interpretability methods for analyzing fairness, but there is something like interpretability is not always for the purpose of fairness. And then also to analyze this fairness and bias, you don't have necessarily to use an interpretability model. So there's definitely something overlapping. And sometimes I feel myself that it is, the more you get into it, you more feel that there's some link in between, but the link does not always need to be exist. And so for the fairness workshop, I believe that just as it suggests in the title, like the fairness is the key part of as a standard for whether it will get accepted or not. Okay. I don't know whether it's okay to jump back to Janning. Yes.
Yeah, sure. So I think the answer is definitely yes, especially if, like, for example, the summarization needs some latest information, for example, latest guidelines, right? For the summarization, or the summarization needs some additional information, so that the agent can help do the Google search or to access a database to provide the additional information. Because a large language model alone, its knowledge has a cut-off time point. For example, it's a trend using data before 2023. It can only know the information before 2023. But if the summarization needs latest data, latest information, the agent can help to find the latest information and incorporate the information to the summary. Yeah, okay.
Yeah, I think that's a good answer to that. I hope it answers your question. We have another question for FAIMI. Maybe a LAM question. No, there's no LAM question. What are the evaluation measures to evaluate the biasness, like the bias of the model? I can see Andrew is typing, but do you like to answer in live, maybe?
Yeah, I was just trying to answer that one in the chat, but there are quite a few metrics. The metric that you use really depends on the application. So if you're doing classification problems, you would look at the difference in accuracy, for example, or difference in sensitivity between protected groups. If you're doing segmentation problems, you would compare dice scores. So there's quite a few metrics, and I don't have time to go through all of them, but I would suggest maybe to start off with one of the review papers. So if you look at the FAIMI resources page, which I think Nina has already put into the general chat, right at the top of that resources page is a list of review papers on AI fairness. My favorite one is probably the Merabi paper. So have a look at that one. I'll put that, well, maybe Nina can put it into the chat. I'll send it to Nina and she can put it into the chat.
Sounds good. Okay. I'll send a link to the chat, so if anybody's interested, you can take a look. I didn't see any questions popping up, and then also we're sort of like already very close to the time that we're supposed to end the session. So I probably will call the session. I wanted to thank all of our 3 presenters for their presentations of these 3 MICCAI workshops. And then I also want to thank everybody for attending this part of the session. And then I I hope that everybody will have a very nice session for tomorrow, which is the last day of our summer school. And then also, please don't forget to sign up the mentorship program if you wanted to, because tomorrow is the deadline for signing up as a mentee. Thank you so much for today. And then I think I will end the recording, and then I will call the session for today. Yeah, thank you all.
Thank you. Bye-bye.
Bye.